hydro desulfurization reactor, which you will find at the beginning of the hydrogen production plant, and very simple as example for the fixed bed A reactor. The hydrogen production unit require ultra clean feed. Sulfur removal is very critical to protect the reforming catalyst. Two hydrotreating reactors like the hydro desulfurization reactor are used at the inlet. Okay, we must remove the sulfur from the feed. This is what we mean by these two type of reactor, R1 and R2 in the hydrogen production plant. Why we remove the sulfur? Because even 1 part per million from sulfur poisoning the nickel catalyst which used in the reformer. So your target is to remove all the sulfur A component from the feed. Sulfur compound in feed, like what? Like mercaptan, thiophene, disulfide, RSSR, or carbonyl sulfide. We need to remove all of them. So we will do a process of hydro desulfurization. This process can be divided into two steps. The first step is to make hydrolysis for the sulfur component and put it in H2S shape. Okay, this reactor R1 will work with a catalyst, which is a COMOX cobalt molybdenum catalyst. Okay, on alumina, working at temperature between 300 to 380 degrees C in atmosphere of hydrogen to switch all the sulfur component we mentioned before into H2S. And by this way, we can feed this stream to the second reactor, working with zinc oxide, working with a zinc oxide. This catalyst working with zinc oxide will remove all the sulfur component and switch those sulfur component into, the catalyst will switch to zinc ZNS, and the stream will go out clearly without any amount of sulfur. Okay, here we discuss the purpose of this reactor. Act as final guard before ZNO bed, zinc oxide, the target hard sulfur compound such as thiophene, protect the zinc oxide bed from overload. And this is the theory of removing the sulfur component from the feed going to the reformer. As we mentioned before, types of the sulfur compound removed: thiophene, benzothiophene, a heavy organic sulfur compound. Okay, so we inject hydrogen with the feed. For the hydrolysis R1, we switch all the stream to H2S beside the main stream of the natural gas or whatever of gas from the refinery, and then we will pass this through the zinc oxide catalyst. All the reactors flow direction from top to bottom, and you can pass the second stream to two reactors for the zinc oxide, reactor A and reactor B. Okay, this help to work in parallel or in series, or work only with one reactor in service. Okay. The feed need to be preheated in a side stream related to the reformer to increase and bring the reactant to the suitable temperature, which is around 360 degrees C at 28 bar gauge. Okay, by heat exchanger related to the reformer. As we mentioned before, the zinc oxide switched by absorbing all the H2S to ZNS. This means that there is a suitable time to remove this catalyst and insert another new catalyst after a certain time from absorption. Okay, related to certain working hours, because this reaction H2S plus ZNO will give you ZNS and H2O. This happen at 300 to 400 degrees C. There is a lifetime. Why there is a lifetime? Because all the bed saturated with the sulfur, and you need to make a regeneration away from the reactor. For this reason, he put two reactors. You have to work in parallel or in series. You have to choose something like that. Okay, this is the stream. Switch it to H2S and the natural gas, for example, in R1. Then you go to R2 H2S free gas, and the Zn will be switched to ZnS. ZNO is protect reformer catalyst from sulfur poisoning, prevent irreversible damage, ensure long catalyst cycle A length. Impact of sulfur on a reformer, which is deactivating the nickel catalyst for sure, and the cause coke formation, will lead to tube overheating and reduce the hydrogen purity and quantity. This is an example of fixed bed reactor, simple fixed bed reactor in refinery or in gas plant to remove the sulfur from natural gas stream. And we mentioned the main parameter related to the fixed bed reactor, and the main troubleshooting also we discussed. And finally, I want to clear to you that you will find through our lecture that there is a many type of catalyst related to the fixed bed design, and we will see together the DHT, for example, catalyst. This is a type of a fixed bed. We will see the hydrocracking catalyst, another type from the fixed bed, and the multi-type from the catalyst selection you will find in the hydrocracking fixed bed. The fixed bed reactor type you will find all over the chemical industry, maybe in petrochemical also you will find natural gas processing for removing HG, very famous as a fixed bed reactor. You will find in the natural gas processing industry also. So this we described today one of the most important type of reactors, which is a fixed bed reactor. I hope this lecture was simple and easy for you, and I want to thank you and appreciate all moments you passed during this short video. Thank you all.